that the Bernoulli's equation finds its applications in three types, in three equipments that what you used in your laboratory. One is the Venturi meter, the second is the orifice meter, and third is the pitot tube. So today I will be covering Venturi meter, orifice meter, as well as the pitot tube. Actually, derivation is not necessary, but let us see how we can go ahead. So you know that the venturimeter is an instrument which is used to measure discharge in the pipes. Suppose you want to measure the discharge in the pipes, then you can fit a venturimeter and then measure. So how you measure, I will tell you later on. So same orifice meter is also used to measure the discharge in the pipes. So what is the here? And these two instruments, that is venturi meter as well as the orifice meters, are used to measure discharge in the pipes. Whereas there is one more application, that is pitot tubes. So pitot tubes are generally used to measure the velocity of flow in the streams. I will also show you that how pitot tube can also be can be used to measure the velocity of flow in the pipe also. So that how can we fit pitot tube, and then we can measure the discharge, because discharge is area into velocity. So therefore, so what is the significance of this? Each of this, where it is used, will be discussed. So you know that a venturimeter is nothing but it is a device which is used to measure the discharge in the pipes. So as you know that it consists of an inlet which is equal to the diameter of the pipe. Then you have the convergent cone. Then you have the throat section, that is a parallel sided pipe, and then it will be diverging. So there is a divergent cone and then the outlet. So these are the following parts of a venturimeter. So first we have the inlet, and then it will converge and reduce in diameter to the throat. So here the principle of Bernoulli is used. Says how we can measure the discharge. So the principle on which the venturimeter works is that by reducing the cross section area of flow. By reducing the cross section area of flow. See, so this is the venturimeter. So you know that it consists of inlet. I will just take. It consists of inlet. Now this inlet is equal to the diameter of the pipe only. So this pipe comes here, joins to this. Then there is a convergent cone like this. So convergent cone. Then this is called the throat portion, which is a parallel sided pipe. This diameter is generally 1/3 to 2/3 of this inlet diameter. This diameter is about 1/3 to 2/3. Generally it is 0.5 times the diameter of the inlet. So this is the throat section. After that, there is a divergent cone, so that it will be equal to the diameter of the pipe again. So therefore, the divergent cone will diverge like this and become equal to the diameter of the pipe. So now, so say here, so what is the principle on which the venturimeter works? The principle on which the venturimeter works is that by reducing the cross-section area of flow, okay, a pressure difference is created between the two sections. Okay, so when you try to create a how pressure difference takes place, because area is more, so velocity is less. If velocity is less, then the pressure is more here. So when you come here, because the cross section area is less, velocity will be more. If velocity is more, then pressure will drop. So therefore there is a difference of pressure here and here. So that can be measured by fitting a pressure gauge here. You can directly fit a pressure gauge. So directly it will measure the pressure here, measure the pressure here. So there will be a difference of the pressure. Or you don't want to connect the pressure gauge, you connect a manometer. So when you connect a manometer, it consists of a manometric liquid of specific gravity little higher than the specific gravity of the liquid flowing. Suppose water is flowing, you use mercury here. Okay, so now so because of the difference of the pressure, you know that the pressure is more here, so the high pressure liquid will enter here and displace the liquid. So before you connect to the venturimeter, it will be same, but once you connect it, high pressure fluid will enter here, so this will go down, this will come up. So always in venturimeter, you will say when you did the experiment also, inlet side it will be always go down, and at the throat side it will come up. So there is a difference of mercury level. So that means what is the difference of mercury level? That is the difference of pressure that it is measuring. So if you measure in the laboratory this value of X, then you can find out the using this X, you can go ahead with the calculations and find out the discharge between these two points. So that means the what is the discharge that is flowing in the venturimeter. So therefore, the principle on which venturimeter works is that by reducing the cross section area of flow, a pressure difference is created between the two sections, which can be measured by means of manometer. So by measuring the pressure difference in terms of x, we can find out the discharge that is flowing in the venturimeter. Okay. Now you can always tell me that, sir, how much to reduce the diameter? If I go on reducing the diameter, what happens to the throat? The velocity will go on increasing. If velocity goes on increasing, the pressure will go on decreasing. So large and large pressure difference can be created, so that this difference of mercury level will be more and it is easy to measure. But can we do that? So we cannot do that. We can do it to a particular extent. So that's why in general practice, it is generally kept equal to one third to two thirds of this diameter. If you go on reducing the diameter too much, the velocity will increase so much, the pressure will come down and may reach vapor pressure. When it reach vapor pressure, so this will turn into, the liquid will turn into vapor bubbles, and these vapor bubbles will be carried to high pressure region where it will burst or collapse. These bubbles will collapse, causing damage on the boundaries, or cavities may be formed. In order to avoid cavitation, the throat diameter is generally kept equal to one third to two thirds, or zero point 0.5, half of the inlet diameter. So that is what is to be understood. Okay. The next thing is that you can see that the convergent cone is of a lesser length. So this angle is also given, and this is little bit longer length. So what happens is that, so here the velocity is less, here velocity is more. So acceleration of the fluid is taking place. Okay. So acceleration of the fluid will take place in a very short length, so that it comes to this point. Then here velocity is more, here velocity is less. So retardation of the fluid is taking place. So when you have retardation of the fluid taking place, so what happens is that, so here because of the retardation of the fluid, so here the flow might get separated out of the this boundary. So therefore, in order to see that flow will converge here, so this is kept little longer, so that it will take time, and then it will stick to this boundary and flow. So that's why this is of a little bit longer length. So these are some of the practical things that you can always have. So now there is a chances of flow separation from the boundary in the diverging portion, so there will be more loss. So that's why we don't connect manometer between this, because you can always ask me a question that, sir, velocity is more here, velocity is less there, so there is a difference of pressure. Why don't you connect between these 2 points? Why don't you connect to throat and the outlet? So we cannot connect, because there is a chances, though we take precaution, there is a chances of, because here acceleration of fluid, so suddenly it comes through this and passes, and the loss is quite very negligible. But here there is a chances that flow gets separated and eddies might form, and so there is a loss between these two. So that's the reason why we don't connect. So your CD value will come down like anything. So that's the reason why, so we don't connect between these 2 points, we connect between these points, that is inlet and always at the throat. So if you're when you were in the fourth semester and doing the experiment, you might always asked your professors that why manometer is connected to the inlet and also the throat, why not to these 2 points? So these are some of the questions that you should ask always, or you should start thinking about these questions. Okay. So now here, because of this convergence, so there is a gradual flow that is taking place. That means that so when the flow is taking place, it will always stick to the boundary and come, so the losses will be less. So that's why we find CD values, that is coefficient of discharge, is generally 0.98, 96, 98, 97, like that. So okay, but losses is generally quite less when you compare to the orifice meter. So when this is used, so this is generally used in most of the places where we want to measure the discharge in the pipes. Because of this, because the losses are quite less. So that's the reason why. And but what is the one drawback is that it needs little more space than the orifice meter. Orifice meter is simply plate with a hole, that's all. So that is orifice meter. But here it has got a convergent, it has got, so when space is not a constraint, you can always go for venturi meter. Okay, so this is all I told. The basic principle on which is that it reduce the, by reducing the cross section area, the pressure difference is created between inlet and throat. So which can be measured by means of a differential manometer, or you can use the pressure gauges, and that will enable us to measure the discharge. How we will measure the discharge? See here, come to this. So now this is section 1, this is section 2. So apply Bernoulli's equation between these 2 points. Okay, when you apply Bernoulli's, so P1 by rho g plus here velocity is V1, velocity is V2. So that's why I'll start applying Bernoulli's equation. So P1 by omega or rho g plus V1 square by 2g plus Z1 is equal to P2 by omega plus V2 square by 2g plus Z2. But here I have not added any loss. So therefore simply neglecting the losses. So now, so when I come here, so for example, I will come to inclined venturimeter also. For horizontal venturimeter, you know that section 1 and section 2 are at the same line. So Z1 will cancel with Z2. So therefore, you will have P1 by omega plus V1 square by 2g should be equal to P2 by omega plus V2 square by 2g. Now, so coming to this, so P1 by omega minus P2 by omega, bring this V1 square to this side, so it will become V2 square by 2g minus V1 square by 2g. You represent this difference of pressure. So this is called the pressure head at 1, this is called pressure head at 2. So you represent this P1 by omega minus P2 by omega as nothing but h. Okay, so I will represent that as h. So therefore this entire difference, this is called h, is nothing but the difference of pressure head, because this is meters of water, this is meters of water. So this h is V2 square by 2g minus V1 square by 2g. So now, since in this equation we didn't consider, because this equation came from equation 1, since we didn't consider any losses, the velocities that you have here is nothing but the theoretical velocities. It is not the actual velocity. Actual velocities are quite less than the theoretical velocity, because if you consider the losses, so these velocities will be quite less. So that's the reason why these two are called the theoretical velocities. Therefore, when you apply Q is equal to A1 V1, so Q also you will get as a theoretical discharge. It is not actual discharge. Actual discharge is quite less. So if I represent Q theoretical as the discharge, now I can write V1 as Q divided by A1, because area of the inlet. So this is theoretical because V1 is theoretical because you didn't take any losses. So similarly V2 is also theoretical, which comes from theoretical discharge divided by A. So because Q is A2 V2, Q is A1 V1. So now you substitute these things in the equation 2. So when you substitute, so you will get something v1 square by 2g. So 1 by 2g I have taken out. So instead of v2 square I have written as q square by a2 square minus this is v1 square. So therefore I have written as q theoretical square by a1 square. So take out q theoretical, so here, and then you can write a1 square a2 square, so which will become a1 square minus a2 square. So what will be q theoretical? So q theoretical is nothing but this q theoretical square will become a1 square a2 square into 2gh by a1 square minus a2 square. So therefore q theoretical is nothing but a1 a2, which you know already, that is a1 a2 root 2gh by root of a1 square minus a2 square. So but actually what is flowing? Actually actual discharge is flowing. So therefore this because you didn't consider any losses, this q theoretical is quite more than what is q actual flowing. So therefore what we'll do is we'll try to reduce this value by multiplying by a coefficient known as coefficient of discharge. Suppose if this value is about 10 meter cube per second, this consists, suppose you multiply by 0.9, so 9 meter cube per second you will get. So this 9 meter cube per second is nothing but the actual discharge, whereas 10 meter cube per second is known as theoretical discharge. Therefore, for this expression, just to account for the losses, I will put a coefficient this. So therefore, I will introduce one particular term known as coefficient of discharge. So what is coefficient of discharge? Coefficient of discharge is nothing but ratio of Q actual divided by Q theoretical. So therefore, I will measure uh, Q actual by multiplying CD to this particular formula. So therefore, this will be the actual discharge that is flowing in the venturimeter. So now, if you know the area of inlet, if you know area of throat, and if you know H, which is P1 by omega minus P2 by omega, that is if you measure the pressure. That's what I said. By measuring the pressure, that is H, P1 by omega minus P2 by omega, I can find out the discharge. So that's why now what is the principle behind this is that by reducing the cross-section area, we created a pressure difference that is H. So by measuring this H, I can measure the discharge by knowing this few properties of area, area of the throat, area of inlet and all. So this is how the formula is derived. So now for you, for the gate, this all derivation is not necessary. Only this formula is sufficient for you, because I have found that there are few problems that are asked in the gate. So that simply you take this, multiply the areas and they're like this, and try to find out this H, substitute and get discharge and tick this answer. So you know already this formula, so which you can use it. So what is this H now? Okay, so CD is generally for venturimeter is 0.96 to 0.99. So now here, see, this is the, so I will try to derive what is that H. So, okay, you know that I have already taught you the pressure chapter. So now when the pressure here, high pressure enters, then displaces the liquid by an amount X, for example. So let this distance be Y. Okay. Now you know that this is one continuous liquid, So therefore, at any horizontal level, the pressure should be same. So pressure at C will be equal to pressure at C dash. So therefore, I'll write the expression. So pressure at C is equal to pressure at C dash. So I'll start from here. So P1, what is the pressure here? It is P1 by omega. Okay, P1 by rho G, whatever it is, P1 by rho G, but it is meters of that is liquid flowing. If I want to convert into meters of water, I have to multiply the specific gravity of that particular liquid which is flowing. It can be water, it can be oil, it can be petrol, and anything like that. So therefore, if oil is flowing, P1 by omega is meters of oil. If I want to convert into water, I will multiply by the specific gravity S, because if it is oil, I will multiply by specific gravity of the oil. So it gets converted into meters of water. So it's always convenient to measure in terms of meters of water. That's why I'm doing all these things. So what is the how to convert into meters of water? Here pressure is P1 by rho G or P1 by omega. I'll multiply by S to convert into meters of water. As we move downwards, pressure increases. So what is here? It is Y meters of liquid. Y meters of liquid. If oil is flowing, then I will multiply by S to convert into water. Then I'll come down by X. So then I will take that X and I'll multiply by the specific gravity. What is flowing here is only this liquid. So I'll multiply by S. So then I will get the pressure at C. Now when I come here, what is the pressure here? It is P2 by omega. I'll multiply by S. So to convert into meters of water. Till here it is Y meters of liquid. So I'll multiply by S. But here it is specific gravity SM. So I will take X. It is X meters of this liquid, and I will multiply by SM, because it is the specific gravity of mercury, for example. But here this side it was this liquid. So I have to be very careful. This all I have taught you there. So that's why. So I've written like this. So P1 by omega is the meters of liquid. I'll multiply by S to convert into water. Then I will take Y meters of liquid. I will multiply by S to convert into water. Then X meters of liquid. I'll multiply by S to convert into water. Similarly, I'll come here. P2 by omega is meters of liquid. I'll multiply by S to convert into water. So I'll take Y meters of liquid. I'll multiply by S to convert into meters of water. Then I will take X meters of manometric liquid and multiply by its specific gravity, which is SM. So this YS and YS gets cancelled out. So I'll bring this P2 by omega this side. So therefore, P1 by omega minus P2 by omega into S will be equal to X into SM minus X. So now I'll bring this S this side. So therefore, so here you had P1 by omega minus P2 by omega as this. So therefore, in the laboratory, H used to use it as X into SM minus S by S. So what is this? In our derivation, we have used P1 by omega minus P2 by omega as H only. So therefore, whenever you want to use in the equation CD into A1, A2 root 2GH, H is nothing but X. So if you remember, your sir might have, because I have not taught you the lab. So there they have told directly you take 12.6 X. So I think in the laboratory when you did H, you took it as 12.6x. Why 12.6x? They have not if you were not asked, so they have not told also. So here specific gravity of mercury, because we have used mercury, that is 13.6. We have used water in the venturimeter, so it is 1. So 13.6 minus 1 is 12.6 divided by 1, because water is flowing. So therefore it became 12.6x. So that's the reason why you used to use H as equal to 12.6 times X. Suppose petrol is flowing there, then you use zero point 0.9 here, zero point 0.9 here. So it will not be 12.66. There the confusion. So I used to ask in the Viva questions that if petrol is flowing, what is this equation? They used to tell always 12.66, because it was taught like this, 12.66. So this is the derivation that you should always remember. So where you should know that how to convert H, that is meters of liquid, when you're using in the equation. Okay, so these two equations. So when the pressures, sometimes the pressure gauge will be connected, so directly P1 P2 will be given, then you directly divide by specific weight of the flowing liquid, then you will get H. So H is two formulas are there. One H formula is P1 by omega minus P2 by omega. Another formula is X into Sm minus S by S. So these two you note it down so that you can solve the problems. Now, so what is the change when there is an inclined venturimeter? So I will not do the derivation. So this is the inclined venturimeter. So because here you have a convergent cone throughout and then the divergent cone. So now this is section 1, this is section 2. So here we had because if you see in the horizontal venturimeter, I had passed this section here only. So Z1 was equal to Z2. Okay, but in the inclined venturimeter, it doesn't happen like that. So here I will take this as point 1, which is at a height Z1. This is point 2, which is at height Z2. So therefore, the difference between 1 and 2 will be Z2 minus Z1. Difference between 2 and 1 will be Z2 minus Z1. So this is point 1, this is point 2. Same thing when the water flows, the pressure is more here, pressure is less here. So high pressure will always on the left side, it will go down, and the right side, it will move. So on the throat side, it will move up. So there is always a difference in the mercury level, which is X. So I have noted this as Y between section 1 and this point. In the earlier case it was horizontal, so I had marked it as Y. So and the difference between the point 1 and point 2 is Z2 minus Z1. Okay. So now for reference I have taken same Bernoulli's equation will apply. Same thing I will do, but I cannot cancel Z1 and Z2. Is it not? So because it is not horizontal, there is a difference of the level. So what I will do is P1 by omega plus Z1. This, so I'll combine this and bring this to this side. So I will write it, instead of writing P1 by omega minus P2 by omega, I will write it as P1 by omega plus Z1 minus P2 by omega plus Z2. So this right hand side is same as of our horizontal venturimeter, which is V2 square by 2G minus V1 square by 2G. So this entire thing I'll name it as H now. In the last time, Z1 was cancelling with Z2, so it was P1 by omega minus P2. So this is H now. So please remember. So now your derivation will continue like this. So in the previous case also, you had continued the derivation. So I will not do the derivation now. So because, so where I continued, so here like this. So I see, so this is H. So I named it this as H. So from here onwards, the derivation will start as Q theoretical and all this. So there also it will be the same thing. So now if I continue and take instead of if because the V1 and V2 are theoretical velocity, so therefore I'll substitute V1 as Q theoretical by A1 and V2 I'll substitute as Q theoretical by 2 and I'll get the same derivation. So it's the same answer, but only thing is H is this one. Okay, because of this inclined venturimeter. So now, so therefore I will introduce CD value. So whether it is inclined venturimeter, horizontal venturimeter, or your vertical venturimeter, the formula remains the same. So what about H? So now, so when coming to this, so again, the pressure at C is equal to pressure at C dash. So now start from here. So pressure at 1 is P1 by omega. You have to multiply by S to convert into meters of liquid. Then, so from here you are coming down. How much you are coming? Y you are coming on left limb. So Y into S. Then X you are coming to reach C. So x into s. Then when you start here, it is P2 by omega. You multiply by s to convert into meters of water. Then you this extra thing is there. So what is that? Z2 minus s. So what is there here? This liquid is coming here till here. Okay, till this y point. So therefore Z2 minus Z1 is meters of what is liquid flowing. If I multiply by s, it will be converted into meters of water. Then from here it is y only up to here, so y into s. Then but here it is mercury, so it is x into sm. So now what I will do is P1 by omega. Okay, this minus z1 s, I will bring it to this side, so it will become plus z1 into s. Then I will take this P2 by omega this side and add this. Okay, this minus z2 into s this side. So minus into minus is this, when this is brought, it is minus. So therefore minus into plus z2 is minus z2 into s. So now what did you find out from this expression? So here you got the same thing, which is P1 by omega plus Z1 minus P2, which we represented as H in our derivation. So here. So now the same H we are representing. So therefore, whenever it is an inclined venturimeter or your vertical venturimeter, you have to represent H as by this formula. You can apply this to horizontal venturimeter also, but in horizontal venturimeter, since Z1 will be equal to Z2, this will cancel out. So this is a general formula for horizontal venturimeter for H, horizontal, vertical or inclined. So you should know how to find out this H by using this formula. You substitute the value of Z1, Z2, this value, and you will get H. So now the formulas are, this is the formula. So H is got from either this formula, which can be applied to any type of venturimeter. But only thing is, for horizontal venturimeter, these two will cancel out. That's all. So always H is x into Sm minus s by s, or by this formula. Okay. So note. So now this is the formula which is you are using for venturimeters, and H is this formula which we derived now, which is P1 by omega plus Z1 minus P2 by omega, but only for horizontal venturimeter, since Z1 will be equal to Z2, this will cancel out and become this. So therefore this is one formula. If you want find H by another formula, which is x into Sm, whether it is horizontal, vertical or inclined, the formula remains the same. Okay. Okay, with this we can solve the problems. So for example, so there are a few things that how to convert into this P1 and all is to be known, which because my pressure chapters and whatever I did there will become useful to you now. Okay, so here it is given that horizontal venturimeter with inlet diameter 25 centimeter. So D1 is 0.25, throat diameter is 0.15 meters. It is used to measure the flow of water. The pressure at the throat is 30 centimeters of mercury. So please note here, it is centimeters of mercury, in the sense that it is already given in terms of head. So you should not write P1 equals 30 centimeters of mercury. So what you should write here, P1 by omega you should write, P1 by rho g. It is already directly given as P1 by, it's not P1. But here at the throat, it is P2. So pressure at the throat means P2, pressure at the inlet means P1. So when they say like this, if it is always given in terms of water or mercury or oil, always meter units are given or centimeter units are given, it is already pressure head. But this unit is pressure units. So you should note that this inlet is P1. So it is only P1, it's not P1 by omega. So here the difference is there. So you have to know, because we have done in Bernoulli's equation also the same thing. So how to convert now? So this, see here, D1 is 0.25. So A1 you calculate, D2 is given, so A2 you calculate. So P1 is already given, which is 200 kilonewton per meter square. So now what is why I gave separately is P2. You should write first 0.3 meters of mercury. Okay. So vacuum means it is minus. So if you don't introduce minus, so please note down all these points. So minus means it is vacuum. So you have to introduce a minus sign. So since it is mercury, you have to convert into water, because it is always better to convert into why water? Can anyone tell why water, meters of water? Because water is flowing. If it was oil, then you should convert into oil. Because if oil was flowing here, you should have converted into meters of oil. So this also mistake will be generally done. So since water is flowing, I have converted this zero point 0.3 meters by multiplying by specific gravity. I'm converting to meters of water. So can anyone tell what is P1 by omega? What should I do for this? To convert into water, I have to divide by specific weight of water. What is specific weight of water in terms of kilonewton per meter cube? It is 9.81. So 200 divided by 9.81. Okay. So this all I have done very rigorously in the pressure units. So there should not be any problem. So those who have missed the pressure units will find it difficult. So that's the reason why I told not to miss the classes during my first few lectures, because all basics were covered there. So now here, so now what is H? So since the pressure was given, so please note that it is P1 by omega, because horizontal venturimeter, it is P1 by omega minus P2 by omega. So pressure is given as 200. I am dividing by specific weight of water because water is flowing. So please note that since water is flowing, I should divide by specific weight of water. So this 4.08 I have already converted into meters of water. So you can also do by two methods. So since this 30 centimeters of mercury is given, so you could have written as P2 as, okay, P2. So that you have to write it as you can multiply by specific weight omega into H, specific weight of mercury, and then convert into kilonewton per meter square. After that you have to divide by 9.81, so you will get the same answer. So there are two ways of doing this. So if already meters of water is given, meters of mercury is given, you can always multiply by specific gravity to convert into water. Okay. So this is one thing you have to remember. So now I got H. Take this H and substitute in the equation. So CD A1 A2 root 2 GH root of A1 square minus A2 square. So when you substitute, so 24.467 CD is given, so you will get the answer. So this answer will be ticked, so that this is all calculations you have to do it and substitute in this equation and you will get this answer. So this is how you find the discharge. So the why I gave this problem is that one thing you should understand how to why you are multiplying by 13.6. That's because it was given in terms of mercury, so I have to multiply by 13.6 because I am dividing by multiplying by 13.6 to convert into water. Suppose the same thing is given, if suppose to measure the flow of oil of specific gravity 0.8, so what would have done for this? Can anyone tell? It is given as P2 as given as P2 by omega is given as 30 centimeters of mercury vacuum. Then it will become minus 0.3 meters of mercury. Suppose it is oil is given, what would have done for this answer?
Sir, minus 0.3 into 1 into zero point 0.8 into 9.81.
That is P2 you will get. Okay. Okay, good.
Yeah.
You will get P2. Then then what do you divide? What you divide? Omega is what?
Rho into G.
Now, what is rho? What is G?
G is 9.81. Rho is zero point 0.8, sir.
Ah,
Specific gravity of oil.
0.8 specific. Rho is density.
Sorry, density, sorry, sir.
Ah. So best is what you should do is when 30 centimeters of mercury vacuum is given, when oil is flowing, first you multiply by 13.6. It gets converted to water. So minus 4.08 meters of water. Since oil is flowing, you divide by 0.8. So it becomes meters of oil. So further calculation you have to do. So same thing I will tell you how it is. So because this all you should understand. So suppose as you told it is 0.3, 0.3, because it is mercury, I multiplied by 13.6, multiplied by 13.6, okay, into 9.81 you said, because it is specific weight of mercury. Okay, so then this was only P2. I want now P2 by omega, so I will divide by, because oil is flowing, I should divide by 0.8 Rho into G, what you said. Specific weight of oil is 0.89. So this 9.81, 9.8. So what I told, same thing I told. So minus zero point 0.3 into 13.6 is to convert into water. I left it here only because water was flowing. If oil was flowing, I would have divided by specific gravity. So I have divided by specific gravity. So to convert into meters of water to meters of oil. So these are very important in this, because the conversions you should get up for this. So that's why how to convert from meters of water to meters of oil, or from meters of oil to meters of water. Okay, so first is mercury to water, then water to oil, like that. So by dividing by specific gravity of oil, I got converted into meters of. So here also 200. I have to, what I have to do is 200. If oil was flowing, I will not divide by 9.8. I will divide by 0.8 into 9.8, like that. Okay. So these things you should note. Another thing is minus sign is introduced to for the vacuum. Okay. So next problem. So venturi meter 150 by 75. So this becomes the throat diameter. This becomes the inlet diameter. So again horizontal pipeline. Z1 will be equal to Z2. Okay. So here oil is flowing. See here, oil is flowing. Okay. So here the mercury level difference in U-tube manometer connected to inlet and outlet is 175 millimeters of mercury. So again here the difference of the level is given. So this is nothing but X for you. Okay, directly the difference of mercury level is given. So if this X is given, so then you can convert this to H by using X into Sm minus S by S. So that's what I'm going to do here. So this D1 is given, so I can find out area. D2 is given, I can find out area. Specific gravity of flowing liquid is given, which is 0.9. Here water is not flowing. So specific gravity of mercury is given here. But X is, so how to find out H? So H is no need to use P1, P2 and so that all confusion is gone. So here you can use direct formula, that is X into Sm minus S by S. So X is given, Sm is because mercury is used, and here oil is flowing. Divide by S. So you will get directly this meter, whatever is flowing, that you will get now. So H is nothing but what oil is flowing. So you will directly get 2.469 meters of oil. Take this and put it in the equation. You will get the answer. So now CD is given, area is known, A2 is known, H is known. So when you will get the discharge. So this is another kind of equation. There in the first problem, P1 and P2 were given. So I used the equation. Here in this problem, X was given. So I used H is X into Sm minus S by S. Here also again it is a horizontal pipeline. But what is happening is that here head of water is given, so water is flowing. So you have to find the rate of flow, the discharge, for which the throat pressure will be 2 meters of water. So directly it is given as 2 meters of water. Okay, so therefore at the throat it is P2 by, because it is given in terms of water, so it is directly P2 by omega or P2 by rho g. Okay, so what is the in the pipe means it is always inlet. So here it is given as 3 meters. So see, please note why I gave this problem. One is gauge unit, another is absolute units. Both should be same. So what should you do for this 3 meters to convert into absolute units? Or what should you do for 2 meters? So both should be same units. So it's already 2 meters of water absolute. So how do you convert this gauge to absolute? Absolute pressure is equal to
atmospheric pressure plus gauge pressure.
Gauge pressure. So gauge pressure is 3 meters. What is atmospheric pressure in terms of water? Atmospheric 10.3.
101.3.
10.3. 101 is kilonewton per meter square. So in meters of water is 10.3. So 10.3 plus 3 meters. So we'll give 13.3. So use 13.3. And this you use 2 meters. Both will become absolute units. So like this you should see the problem. See here. So what I did here now. So since it is given as gauge, I converted to the absolute units by atmospheric pressure plus gauge pressure. So atmospheric pressure, this is standard value 10.3 meters of water. So plus the gauge pressure. So which is that is. So now this is absolute units, this is absolute. Now I can substitute in the formula. Since it is horizontal, I can find out H. So what is H? It is P1 by omega minus P2 by omega. So therefore I will use this. I take this 11.3 and substitute in the equation. So this is how you find out. So that's why I gave this problem. So see that you have to convert. So if you had used directly 3.3 minus 2, your answer is wrong. So they will give one option with the 3.3 minus whatever is how much I gave that. This one 3 meters. You will use 3 meter and 2 meter. So 3 minus 2. What you will do is 3 minus 2, 1 meter, and they will give one option to you, which is wrong. So, but actually it is not 3 minus 2, it is 13.3 minus 2, because this is absolute unit, this is both, or you convert both as a gauge units. Okay, so this is what you should do. So now you substitute in the equation and get the answer. So this option will be, so if you had used this option, so there if with some other this one, this still it will be lesser, you would have ticked that 3 minus 2 and substituted here. So if you have 1 year, so what would have been answer? It will be quite different from this answer. Okay, so these are the changes that you have to note. See here. So here what is what it is given as vertical. So whenever it is given as axis vertical, H is not P1 by omega minus P2 by omega. So that's the difference. So that the here what is given is throat diameter is 75 millimeters. Inlet diameter is always more than throat, so it is 150 mm. Throat is 255 mm from the inlet. So that means the distance is given. Okay, and CD is given. So petrol is flowing. So petrol, so your unit should be in meters of petrol. Okay, so discharge is given, so you have to find what is the difference of pressure between the inlet and the outlet. Okay, so now you can know what is D1. So using D1 you can find A1, using D2 you can find A2. Discharge is given, so they have asked you the difference of pressure between inlet and outlet. So now what is this? I will tell you in the figure. Okay, see here. So now suppose some figure you can write vertical axis. So what is a section? This is section 1. This is section at the inlet, it is section 1. At the throat, because I have placed convergent cone here, divergence. So this will be the direction of the flow. You can make it reverse also. So now this is section 1. I have passed the datum here. So if I pass the datum as I have solved in Bernoulli's equation also, they have said in the equation that Z2, that is section 2, throat is 225 millimeters from section 1. So that's what the distance is given. So therefore, if I pass the datum here, so Z1 will become equal to 0. Z2 will be the distance, so 0.225 meters. So therefore, I have written here Z1 as 0 and Z2 as 0.225 meters. Okay, so rest all is very simple. So you have to substitute here using this Q. You have to substitute here Q actual, A1, A2. Only thing is I wanted this H from this equation. So I'll get H from this equation because all other quantities are known. So once I know H, I'll use the formula now. So what is H? It is P1 by omega plus Z1 minus P2 by omega plus Z2. So what is Z1? It is 0. What is Z2? It is 0.225. I'll substitute and bring it to this side. So like this. So 2.2364, which I got the answer by solving this equation. I want P1 minus P2. So therefore, I will use it. P1 by omega minus P2 by omega is equal to 2.234 minus 0.225 will come to this side as plus. So it will be 2.4614 meters. So what is this meter? What is it? Can anyone tell? What is flowing? Petrol is flowing. So what will be this? 2.4614 will be meters of petrol. So how to get P1 minus P2? Can anyone tell? You have to multiply by omega. What is omega? Because petrol is flowing, it is omega is specific weight of petrol. So you have to multiply by specific weight of petrol. What is the specific gravity of petrol? Is given 0.78. So take 0.78 and multiply by 9.81. So which will be 18.83. So this answer they might. So therefore, if you multiply by 9.81, they will give one answer with 9.81. and one answer with 0.78 to 9.81 like this, and tell you to tick any of the equation, this answer. So you have to be very careful that because petrol is flowing, you should always multiply by specific weight of petrol. So these whenever you do P1 by rho g, or the density also should be like, or otherwise you take if you have used rho g, then you multiply by rho g. Okay, so you have to be very careful. So rho you have to take it as 0.78 into 1000, which is 780. G is 9.81. So anything you can use. So that will be Newton per meter square. Divided by 1000, it will become kilonewton per. So same answer you will get. Yeah. So again, the same thing. The pressure at the inlet is given. See here, vacuum pressure at the throat is given. What is flowing? You just see. Liquid flowing is water. So no. So when water is given, it is very easy. You can convert always to water. Okay, and the problem I've given this is that there is already a loss given. Already a loss given. So first to find out whether with loss or without loss. So how to solve the problem? So here it is given that there is a 4% loss.
Sir, not
Okay.
audible.
No, no, no. I've just connected now, right now. Power has gone in my house, so that's why. Screen is visible.
Yes, sir.
Yes,
Okay.
sir.
Here, there are two types of problems in venturimeter. One is without loss, other is with loss. So when the loss is not given, they will give CD value. If the loss is given, they will not give you the CD value. So that's third. So CD, what is CD? CD will account for the losses always. Okay. So if so, since the loss is given, so then CD value they'll tell you to find out, and they'll not give the value of CD. So this is what you should understand. Now, so D1 is what? 0.3 meters. So using D1, you can find out the area. Using D2, you can find out the area. Okay. So pressure is given 137.3 kilonewton per meter square. P2 is very important. I told you 37 centimeter can be converted to meter, like 0.37 meters of mercury. Because water is there, you can convert into meters of water by multiplying by 13.6. So I have multiplied by 13.6 and converted directly meters of, this is water actually, meters vacuum, because minus sign. Because of vacuum, it is minus sign. Huh. So what is loss? So loss is given as 4% of the differential head. What is differential head? Differential means what is the difference of pressure head? So pressure head at 1 is P1 by omega. Pressure head at 2 is P2 by omega. So 4% of that is loss. So therefore I can calculate the loss here. So loss is 4% of the head. Okay. So you know P1 by omega, you know P2 by omega, substitute there. So when you substitute, because 0.04 into 137 is the pressure head, 9.81 I have divided because it is specific weight of water. This is P2 by omega directly given as 5.032 minus. So I have substituted here and I have got the losses. So when the losses is given like this, then you apply Bernoulli's equation between the 2 points. So using continuity equation, you can get A1 V1 equals A2 V2. You can get that the okay, this relationship between V1 and V2. So pi by 4.3 square into V1 equals pi by 4.1 square into V2. So therefore V2 is 9 times V1. So now you apply Bernoulli's equation between section 1 and section 2. So when you apply Bernoulli's equation, so head loss you account here. So when you account head loss here, So now whatever the velocity that you get is the actual velocity. So since in derivation, when you didn't account for the losses, we introduced CD value. So no need to introduce CD value in this. So because you accounted for the losses. So these V1 and V2 will be the actual velocity for you. So now you know P1 by omega, you know P2 by omega, you know you keep V1 as it is. V2 you substitute as 9 times V1. P2 by omega is known, HL is known. So therefore you can solve for V1. So when you know V1, Q will be A1 into V1. So which is actual, because because this V1 and V2 are actual velocity. So Q will get actual velocity. So no need to find out CD and all. So therefore here, so you substitute the values and solve for V1. So when you solve for V1, you will get velocity, then discharge. So this discharge is actual because you have introduced the losses. The loss is introduced here. So therefore it is actual. So how to find CD value? If you want to find CD value, so what you have to do is Q theoretical you find out, which is without CD, A1, A2, root 2 GH by root of A1 square minus A2 square. Okay, so if you find H, because H is P1 by omega minus P2 by omega is a horizontal venturi meter, you will get this value. So substitute this here. So find out without CD. Now CD is Q actual by Q theoretical. So you will get the value of CD. So they also told you to find out the value of CD, which you can determine. So like this, also find the value of CD. So now using the losses, you got actual discharge. So this is how this will tell you application of Bernoulli's equation. See, now by measuring the pressure difference, I calculated the velocity. From velocity, I got the discharge. So this is the application of Bernoulli's equation. So using H now, I will use Q theoretical. So now Q actual by Q theoretical. What was Q actual? It is 0.1495. What is Q theoretical? 0.1526. That will give me the CD. So CD is coming as 0.979. So like this, with losses also you can determine the discharge. So like this, various types of problems will be there. So you see here, this is an inverted YouTube manometer. Okay, inverted YouTube manometer. You never come across inverted YouTube. So when you use inverted YouTube manometer, when the so when the manometric liquid is lesser specific gravity than the flowing liquid, so then you have to use inverted YouTube manometer. Okay, yeah, we have used the regular YouTube manometer because heavier liquid is used. That is, so that when there is like oil you use but water is flowing, so that time you have to make it YouTube manometer as inverted. That you have studied in the pressure chapter. So here loss of head between the inlet and throat is given. Loss of head between inlet and throat is given, which is 0.2 times the kinetic head of the pipe. What is kinetic head? It is velocity head. What is pipe? Inlet. So it is kinetic head means V1 square by 2g. So loss is 0.2 times V1 square by 2g. Okay. So throat is 1.2 times from the inlet section, that is given. So here the liquid flowing is specific gravity 0.6. So S is 0.6. SM is 0.6 because it is measured by the liquid of specific gravity 0.6. But what is flowing? Water is flowing. So discharge of water you have to calculate. So therefore water is flowing in the pipe, whereas the manometric liquid is lesser than the water specific gravity, which is 1. So here it is 0.6. So you have to be very careful in using the formula. And so all these are same. So SM is given 0.6. Here's water is flowing. So S is 1. X is given, it is measured. So reading is 30 centimeters. So X is 0.3. Head loss is given. So I will not use because see, so nowhere CD value is given here. See here, CD value is not at all given. So you without CD value, you can find out by using Bernoulli's equation and add loss to that. So which you can do it. So now I will find out H because X is given, I can find out H. Okay, this is 0.12. Now derive relationship between V2 and V1 from continuity equation and put it in the Bernoulli's equation. So why this is given? I said this is an inclined manometer. I have drawn a very simple sketch for you. This is section 1. This is section flow is taking place like this. So I pass the datum here. So Z1 is 0. and this distance is given. The distance of throat is 1.2 meters from the section 1, and the angle is given 30 degrees. So it is an inclined manometer at an angle 30 degree with respect to horizontal. So therefore, using this 30 degree and using this 1.2, I can find out Z2. So sine 30 is Z2 by 1.2. So therefore, Z2 will be 0.6. So Z1 is 0, Z2 is 0.6. I'll substitute here Z1 and Z2. Head loss I already determined. Okay, which is point how much, zero point 0.2 times v1 square by 2g, which I will substitute here. So here, so now what I will do is p1 by omega plus z1 minus p2 by omega plus z2. For inclined manometer, I represented this as h. Okay, which you that's why derivation is very important. So this is h, which is got from here, from this equation. So this you put it as h here, and then you solve for this equation. So v2 square by 2g minus v1 square by 2g, HL is zero point 0.2 times V1 square. So now solve for V1 square. V2 can be written as 4 times V1. So therefore, H is now V2 square by 2G minus, so this is 1 minus 1 plus 0.2 is 0.8 minus 0.8 V1 square. So now substitute V2 in terms of V1 as 4 times V1, and H you put it as 0.12. So solve for V1, you will get the answer. So this is how you solve for V1 and then discharge. If you want CD, you calculate Q theoretical, that is A1, A2. I have not done that. So you can calculate Q theoretical as A1, A2 root 2 GH by root of A1 square minus A2 square. Then CD will be Q actual by Q theoretical. Okay. So this is how you do the problems on. So very simple. You have done in your BE days also about this, because very important applications of your Bernoulli equation. One more equipment that you used, instrument that you use for measuring is orifice meter when space is limited. It works on the same principle as, so what is done is that, say, a simple, say, circular plate is introduced here. So this is a cut section. A circular plate with a circular hole is there. So take a piece of paper and make a hole at the center. So water is flowing only through this hole. So you are reducing the cross section area. By reducing the cross section area, you are creating a pressure difference between these 2 points. So by measuring the pressure difference, you can always measure the discharge as you did in the venturimeter. So generally, a pressure gauge will be connected at a distance of 1.5 to 2 times the diameter. So like this, and when the water comes, it will converge and forms a vena contracta. So this vena contracta is that section where the area is least and the velocity is greatest and pressure is least. So there is a difference of pressure between these 2 points which can be measured. You can fit a gauge here, and measure the difference of pressure. Okay, this generally vena contracta is formed at a distance of point, generally about point or equal to diameter. So if the diameter is small d, it will be equal to that distance. Okay, so you can fit a gauge. So if you have seen in our laboratory, you might have seen that this is a orifice plate with a hole. There is a circular plate equal to diameter of the pipe, and exactly at the middle there will be a circular hole where the water enters. So you're reducing, so sudden reduction in cross section area, so eddies will be formed here, lot of losses takes place. So that's the reason why CD value is 0.6 to 0.7 here. There is no 0.9698 like that. So why CD value of orifice meter is less? So that question cannot be asked. CD value is generally less because there is more losses taking place in this area, because a lot of eddies will be formed here. So losses will be formed because of sudden change in the area, sudden change in the cross-section area of flow. So CD will be generally 0.6 to 0.7. So the formula, no need to derive because the formula will be A1 A2 root 2 GH by root of A1 square minus A2 square. Instead of A2, I have written as area of the orifice. This A0, A1 is inlet, A0 is the this area. this area. Okay, if the diameter is given as like something like 50 millimeters or something like that, if this is you can always take this diameter and convert into area and write it. So okay, so this no need to take the area because it is very difficult to measure at the vena contracta, so it is always converted into the diameter of the orifice. So therefore the formula you can write it as A1 as area of pipe at the inlet, A naught is area of the orifice. Okay, what is orifice? Orifice is an opening which is made in the plate, in the circular plate. H remains the same. If it is horizontal orifice, it is P1 by omega minus P2 by omega. It is also given as H into X into Sm minus S by S. Same formulas will hold good. Whether see here, I have written here already. So this is the same formula for either horizontal orifice meter, vertical orifice meter, or inclined orifice meter. So this formula. Otherwise, you can measure. We can find out H from this formula and substitute here. So no need to do the problems because all the problems of venturi meter you can convert into orifice meter by giving the diameter of the orifice. So all these calculations you can do it. So like just for your sample example that an orifice meter with orifice diameter is given. So what is the D naught is given 10 centimeters, which is 0.1 meters, and pipe diameter is given. Pressure gauge is fitted. So here upstream means P1, which is 196.2, and downstream is P2, so P2 is given. So now you can find out, because it is horizontal, you can find out H. So CD is CC, the value of CD is just zero point 0.6. You can determine the discharge. So therefore this also we have done. P1 is given, P2 is given. At the upstream side it is P1, downstream side it is P2. So if you measure this, you can calculate H. Okay, P1 by omega. What is flowing? Water is flowing, so I divided by 9.81. Water is flowing, so divide by 9.81. So this H you take it and put it in the formula. So you'll get the discharge. See here, if you are using venturi meter and you replace by orifice meter for the same setup, so then for the discharge of 100 liters per second, what should be the diameter of the orifice? So we should decide what should be the diameter of the orifice. So now if I take venturi meter, D1 is 0.15, D2 is 0.075, CD is 0.98. Okay, then discharge is 100 liters per second. So if I take this and I'll find from what I will do is like see here, I take first venturi meter, D1 is known, D2 is known, CD is known, discharge is known. So for orifice meter for the same setup, D1 remains the same because the inlet diameter remains the same. Then what should be the diameter of the orifice is to be determined. Okay, so what I will do is I'll solve venturi meter, get the H value, take this H value because discharge remains the same. I will use it for this and find out the diameter of the orifice. So therefore, so when I use venturi meter, you know how to solve this problem because D1 is given, A1 can be determined, D2, A2 can be determined. So then I will find out, I will put discharge here in the formula, H I will determine. Okay, H I will determine. So this H, because the setup is same, okay, I will, because discharge is flowing is same in the orifice meter as well as venturi. I will take out venturi meter and replace by orifice meter. So now because I have to maintain the same discharge, so the pressure difference remains the same. So H remains the same. So I'll take this H and put it in this formula. So I'll take this H and put it, discharge will remain the same. So all I will value, only CD value I'll change because it is orifice meter which is 0.6. So I'll solve for A naught. So I'll solve for A naught here. So if I solve this, so I'll get A naught. So like this. So then what is A naught? It is pi by 4 d square. So I will solve and get it as, see, it is almost came as, so in the previous case in venturi meter it was 150 by 75. Now for this it came, inlet diameter is 150 but outlet this throat diameter or orifice diameter is 93. In the earlier case it was 75, now it is 93 to maintain the same pressure and same discharge. Okay, like this, you just this is about the orifice meter, which you can solve all the problems of venturimeter. You can use it here. So no point in solving many problems because the formula remains the same. Values of h also will the calculations are almost similar to that. So you should know and use it correctly, the equations, and find CD value is quite less because there is sudden change in the cross section area of the flow. So this is about the orifice meter. The pitot tube is used to measure the velocity of flow. So what is done is that, see here, this is the stream that is, all of you carefully see that this is a stream that is flowing. So what I will do is I'll introduce a pitot tube like this. So pitot tube is a simple, like this right angle which is bent at right angles. This is a pitot tube, and this end is facing the stream, the other end is open to the atmosphere, which is above the surface. This is the water surface, so now suppose you want to measure the velocity here, so you insert this tube will be facing the flow now. Okay, and this will be the other end will be open, so it will bend at right angles. So simple glass tube also, you can take a simple glass tube bent at right angles, and this end A is facing the stream, whereas the other end is above, projects above the fluid surface. Okay, so like this. So now, so this is what happens. So the here, if the velocity is v, so take 1.1 here, zero point 0.2 here. Okay, so now what happens as the flow approaches the A? So okay, so flow comes and diverts like this, and some enters. So as soon as it enters, so the flow here, what happens, it comes to rest here. So because as it enters, so nothing, because the flow is taking place here, but when inside the tube it will come to rest. So this point, because here the velocity is v, which has got a high velocity, so therefore it is we get lot of kinetic energy. Okay, so this kinetic energy gets converted to pressure energy, because you know that as the velocity goes on decreasing, the pressure goes on increasing. So now at this point the pressure increases so much because the fluid is brought to rest, so which is called stagnation pressure. So when the fluid is brought to rest, the pressure, because the velocity goes on decreasing, the pressure increases. Because of the high pressure, the water, because this pressure is called as because the fluid is at rest, but has got a very high pressure. So that means this pressure is known as stagnant pressure. So stagnant pressure. Okay. So because of this stagnant pressure, the water will rise above this liquid. Okay, it will rise above this here, and if you measure this whatever the rise, you can measure the velocity. How can you measure the velocity? I'll tell you. So now, so this is because this surface remains constant, it's called the static head. Suppose you represent as h naught, and here it is a stagnation pressure. So now water will rise to amount h, say for example. So this is called stagnation point. So water will rise. So now I have made it to rise to this level. So because of this pressure, the water will rise above the static head. So if you measure this head, it is sufficient. So what is stagnation pressure now? Stagnation pressure is corresponding. So from free surface you measure. So what is stagnation pressure head? It is h plus h naught, because this is h and then this is h naught. Okay, so h plus h naught is known as stagnation pressure. So pressure at A is h plus h naught, whereas pressure at 1 is only h naught, because only up to the free surface. This is free surface here in the tube, whereas outside the tube free surface is here. So both are free surface subjected to atmospheric pressure. Okay, so this is the concept that we are going to apply. So now you apply Bernoulli's equation between section. So again, it is an application of Bernoulli. So I am applying Bernoulli's equation between section 1 and section 2. That is 1 and A. So now if I apply this, all I have explained now, I apply Bernoulli's equation. So what is at section 1? It is P1 by omega. And section 1 is V, velocity is flowing. So V square by 2G plus Z1. Okay, is equal to, at A, it is pressure, stagnation pressure, PA by omega. What is the velocity? It is VA, for example. ZA. So Z1, 1 and A are at the same level. So Z1 will cancel with ZA. Okay. Now before that, so what is P1 by omega? And so what is P1 by omega? It is nothing but H naught, because P is equal to omega into H naught. So what is H naught? It is pressure head, which is P1 by omega. What is PA or P2 by omega? It is H plus H naught. What is at A? It is H plus H naught. So that you have to write it. So that's what I have explained here. So instead of P1 by omega, I'll write H naught. Instead of PA by omega, I'll write H plus H naught. Okay, Z1 will be equal to ZA. Velocity, because velocity at A is stagnation, it will come to rest. So velocity will be 0 there. So you substitute. PA by omega is H naught plus H. If I substitute here, instead of P1 by omega, I'll substitute as H naught. V square by 2G, because velocity is V square. But when you come at A, it will be 0. What is PA by omega? Stagnation pressure, which is H naught plus H. And ZA, Z1 and ZA will cancel out. Okay, so then H, okay, H naught and H naught will cancel out. H naught and H. So what is V square now? V square by 2G is H. So V is root 2GH. So now that's why I always tell that theoretical velocity is root 2GH, root of 2GH, like that, because many a times we have told this. Now I have proved this. Now what is velocity? It is root 2GH. So have I considered any loss here? I have not considered any loss. So this will become theoretical velocity. If I want to convert into actual velocity, I have to measure, I should introduce a coefficient known as coefficient of velocity. So therefore, in our chapters like in Kaplan turbine, in Pelton wheel and all these things, we have used the equation V is equal to CV root 2G, similar to that. So therefore, this is CV is known as coefficient of velocity, which is 0.96 to point somewhere around 0.9698, like that it will come. So now if you just measure the dynamic pressure head H, you can find out what is the velocity. So this way now I proved that. So in order to measure the velocity of flow in the stream, so somewhere here, if I only measure this H, I will get the velocity. So if you just measure the H above the water surface, this in the pitot tube, and if I take root 2GH, I will get the velocity. If you multiply by coefficient of velocity like 0.969798, then I'll get velocity of the flow in the stream. So this is the easiest method to determine the velocity of the flow. So why pitot tube is used? Pitot tube is used to measure the velocity of the flow in the streams. Okay, so these are the things that so now I told you that so further reading I just gave this because you can measure the velocity of flow in the pipe also. So because right in the beginning I told you that you can measure the velocity in the pipe also. How to do this? What I will do is I will take a I'll take a pitot tube and connect it to the YouTube like this. So this is a pitot tube. So this is a pitot tube. It is not exposed to a like this. I have not put, I have connected to the YouTube manometer. Okay, so this is a YouTube manometer which consists of mercury or something like that. So very simple, this one. So this I will measure. So I'll take a I'll take a pitot tube and connect it to a YouTube manometer like this. Okay, why this low, why this down, why this up, I will also tell you. So this, so now this is this exactly at the center. You put a pitot tube here and then connect it to a YouTube manometer. Suppose velocity of flow is V here. Okay, I want to measure the discharge in the pipe. So this is the pipe. So how to measure the discharge? So same thing here, you take 1.1 and here this will become, as the flow enters here it will be stagnation. So this will be the pressure, this is the stagnation pressure. So 0.2 is a stagnation pressure, whereas 0.1 is a usual pressure in the pipe or velocity here. So here velocity will be 0 because it is stagnation. Here there will be velocity V. So now you apply Bernoulli's equation between 0.1 and 0.2. There I have taken A and now I have taken 2. Okay, so now let me write the equations. Okay, so this is some liquid is flowing with specific gravity S. Okay, so now the pressure here is equal to, because this is one continuous liquid, the pressure here is, so why so here, so as you are moving here, so when you come down here the velocity is V, so pressure is something. So when you come over here the velocity will decrease at almost 0. So therefore the pressure is more. So when the pressure is more, high pressure liquid will enter and displace like this. So this will come down and this will go up. So this is always at the stagnation point. There is always the liquid level coming down and liquid level going up in this point. So this you have to note down. So I have noted down as y and this as x. Okay, so when I apply Bernoulli's equation, so again P1 by omega plus y v square, this V1. Actually V1, instead of what is V1, it is equal to V. What is V2, it is equal to 0. Okay, so this is what I have done. So this is, so substitute the values. So Z1 and ZA or Z2 is the same level. So I have cancelled that. So what is V2? It is 0. So therefore I have written as P1 by omega plus V square by 2G is equal to P2 by omega. Okay, so pressure is not 0 because stagnation pressure. This is stagnation pressure. This is the pressure at the section 1. Okay, I will leave it as it is. Now instead of P1 by omega minus P2 by omega, I will this I have to write P2 by omega minus P1 by omega. Please note that I'll make these changes. So V square by 2G is P2 by omega minus P1 by omega. Okay. So this I will keep it as it is. Write the manometric equation. So how to write manometric equation? So come here, P1 by omega into S, then come down Y into S, then X into SM. Then here P2 by omega into S. I'll come down by Y into S. I'll come down by X into S. So that same thing I have written here. So I have written like this. So ys and ys cancels out. So now this is what is P2 by omega minus here. This P2 by omega minus P1 by omega. So this has to be 1. Okay, so make it as 1. Okay, so this is P2 by omega minus P1 is equal to X into SM minus X into S. So now these two are same here. So this has to be P2 by omega minus, I will make the changes later on. So this is P2 by omega minus. So now, so these two are same. Okay, so you got your answer. Okay, which is P2 by omega minus P1 by omega is X into SM minus S by S. So what was this in our venturimeter also? It was H. You can remember this as H also. Okay, H, this is H. So which is X into SM minus S by S. So now the equation is, if I substitute this as X into Sm minus or H, something like that. So I will write as V square by 2G as X into Sm, because P2 by omega minus P1 by omega was X into Sm minus S by S. So therefore what is V? It is root of 2G into X into Sm minus S by S. So you can remember the same formula. What is X into Sm minus S by S? It is H. So therefore velocity is the simple root 2G H. So therefore there H was directly or measuring in the pitot tube. Here H is nothing but whatever that manometer readings you will get, you will measure it and enter here. So here H is in the pipe, it is X into Sm minus S by S. So otherwise the formula remains the same. So therefore H is X into Sm minus S by S. So now you know the velocity in the pipe. So multiply by the area, you will get the discharge. So that's how. So because this all you have not, maybe you have not have told in your this one. So now I have told you how to measure the using the pitot tube by connecting to the manometer. How can you measure the velocity? So the simple formula for V is no need to go ahead with the derivation. Simply take root 2GH. So here, so in the flow you have to measure the head, but here H is nothing but X into Sm minus S by S. Otherwise it is difference of pressure between these 2 points. So therefore you can easily measure H, okay, by using this equation X. So substitute here, you can multiply by CV to convert into actual velocity, because this is theoretical velocity. So this is what you do. So we actually CV into root 2GH. So like this, I have done simple formula that a submarine is moving in a sea, in a sea, and the axis is below the water. A pitot tube is connected in front of the submarine. Okay, so that, and then that is connected to U-tube manometer containing mercury. So difference in mercury level is given as 0.17. So So you have to find what is the velocity of the submarine. So as you have used this formula, so V is equal to root of 2gx into Sm minus S by S. You can always, because X is given, which is 0.17. Specific gravity of manometric, because manometer consists of mercury, so specific gravity is 13.6. Here the specific gravity, because here water is flowing, so specific that is sea water, actually it's not 1, it is 1.025 divided by 1.025. So you can find out the velocity, because nothing is mentioned about CV. I have not taken CV. So directly you substitute here the values and you can find out the, so the submarine is moving at a velocity of 6.4 meter per second. So simple. This type of problems can be asked in the gate examination, because this has come, I think, somewhere. So you have to only, you should know, if you are not known, if you have not done the derivation, you don't know the formula. Simple formula is V is equal to root of 2gh. H is x into Sm. Like that also you solve it. You can note down in your notebook now. So V is equal to root 2gh, whereas H is x into Sm minus S by S. Because it is sea water, you are using S as 1.025. In manometer, you are using mercury, so therefore it is 13.6. So that's how you try to find out the velocity of the submarine which is moving. Here also, see here. So this is one of the pitot static tube, means which is connected to the pipe. So pitot with together with the manometer is called a pitot static tube. So it is inserted in a 30 centimeter diameter pipe, as I did in the derivation. The static pressure is given, which is 12.5 centimeters of mercury vacuum. Stagnation pressure is also given, which is this gauge. You have to calculate what is the rate of flow of water. So mean velocity of flow is 0.875 times the central velocity. The coefficient of velocity is also given here. Okay, so what you have to do is that static pressure head. So what is static pressure head? Okay, so this is inserted so something like a velocity of flow in the stream. You have to find out. So they have given static pressure head. If I refer the diagram of mine, this one in earlier case, not this is not the this is about this problem. See here, this static pressure head is given, H naught is given, and stagnation pressure is given. What is stagnation pressure? It is H plus H naught. So you should know this. If you don't know, then you cannot solve the problem. So therefore here, so using H naught and H plus H naught, you can find out H. So then use it in the root 2gh formula. So that is what you are going to do now. Okay. So now, so what is static pressure? It is H naught. 12.5 centimeters of mercury vacuum, water flowing, so convert into water. So what you have to do is you have to multiply by 13.6. So you will get vacuum is minus, so minus 1.7 meters of water. Then what is stagnation pressure? It is 1.5 Newton per centimeters square. So what you have to do is you have to multiply by 100 square to convert into Newton per meter square. So how do you, what is stagnation pressure? It is H plus H naught. So what you have to do, you have to divide, to convert into meters of water, you have to divide by, because it is Newton units, you have to divide by 9810. So this also conversion, sometimes if you do it by 9.81, it will go wrong. So since this is Newton units, you have to divide, as good as saying P by omega. So specific weight of water is 9810 Newton per meter. So then only it will get converted into water. So therefore H plus H naught, which is the meters of water units, because water is flowing. So you have to divide by specific weight of water. Otherwise you convert this into kilonewton per meter square and divide by 9.81. So now you know H plus H naught, you know H naught, you can find out H. So substitute. So what is dynamic pressure head? It is nothing but 1.1723 minus H naught. H naught is brought to this side. So minus of minus is plus. So this will become H. So take this H and substitute in the equation. V actual. So V, that is CV into root 2gh. So you will get the discharge. So once you know, once you will get the velocity. Once you know the velocity, you can find the discharge. Because here it is given that this is nothing but